Okay, I'm Samuele Burattini from University of Bologna, and today we'll talk to you about some exploratory work that we've done in looking at linked data for ecosystems of digital twins. This is a joint work with University of Saint-Etienne, Antoine Zimmermann, and my colleague Marco, who is sitting somewhere in the room, and from Modena Reggio Emilia, and my supervisor, Alessandro Ricci. So first, I would like to explain why in our research group we are looking at digital twin ecosystem and what do we mean by that. So essentially, we all know that a digital twin is a model of an asset. And for instance, I have a robot and I create a nice model of my robot and I'm happy with it. But if we zoom out and we start to consider bigger context, like a whole factory, I may have many robots, and the digital twin of the whole factory becomes a challenging thing to build, because how do I model something that is that complex? And if I use a monolithic approach, I may fail to understand the relationships that may be dynamic, and it really is impractical for a large scale context. So what we can do is divide and conquer and essentially have digital twins of all the assets that we want to represent and connect them in some form of network of relationships. And we end up with having this sort of ecosystems that we also go into call a web of digital twins. And my colleague Andrea this afternoon will talk to you a bit more about that vision. And in this context, the main challenge that we see is heterogeneity, and the first speaker before me really put an emphasis on that. And we have heterogeneity on the asset level, so you cannot see it, but I may have a robot, a car, or a person. I can make digital twins, and we've seen lots of application. And we may have heterogeneity in the technologies, so the shape that my digital twin end up having is different, and in the communication and interaction protocols that are used for applications. And the applications that may want to use the digital twin for some goal and some collecting the data that they are producing and everything may prefer to decouple from all this mess and use the digital twins as services. So how do we do that, and how can we make this more effective in these complex ecosystems? We've been looking at representations, and the overall objective that we try to summarize in a sentence is that we would like to have representations of digital twins that allow consumers to join an ecosystem, understand which digital twins are present and available, what assets are being modeled, how these assets are modeled, and what services the digital twins are offering, but also what is the real-time state and the history of the digital twins. And the perspective that we've looked at are the perspective of consumers, so applications, stakeholders, they may want to use digital twins for their goal, but also operators, and we've seen some talks about DevOps and how it is complex to manage running digital twins, and in this case, having a very clear idea of what's all this mess that I have to handle, it's very useful. So we would like to have a representation that serves both kind of users. We ended up drawing up some requirements. This doesn't need to be a full list, but these are the ones that we consider relevant. And the main one is identification, so clear identification of the digital twins as my software instance and the asset as my actual physical thing. A representation of the model or the models that we have. We can use like the properties that I'm representing about that asset and the overall fidelity that the model has, and many different things. We would like to have the representation of the state. I mentioned before the real-time state and the past state of the twin, and a representation of the services and how do I access those services. So what are the interactions that are provided by the services, the APIs, for instance, prediction or simulation, what if scenarios and whatever. And we will also like to have information about the deployment context. So where is the digital twin running? What are the requirements for this digital twin to be moved somewhere in my computing spectrum? and also information about metrics and state of operation. So is this digital twin really performing well as it should, or is something broken? Is something out of place? And finally, information about the data sources for provenance of the data, but also data storages, because maybe I have some dedicated storage that I want to direct consumers for data intensive operations, like downloading all the history. So we have been looking at some representations in the state of the art. These are different models from both standardization bodies and academics. And we basically realized that none of them cover all of these properties. And so we started looking into how we could tackle this kind of problem. And our approach is based on linked data. And the idea is that linked data can act as a barrier between the applications and the consumers that the stakeholders that we mentioned to the digital twins. And for those who are not familiar with linked data, the idea is that the semantic web basically builds a web of data that consumers can directly browse and interpret, and is based on the resource description framework, on ontologies to share knowledge, and on the linked data platform for organizing content. So our proposal is twofold. First, we try to build directly from those requirements an ontology that we call a core ontology, because we expect that it might be refined for specific application scenarios. And here you can see the main entities that are the ones that I mentioned before. And especially, we modeled explicitly the history of the digital twin, because we also propose an approach based on the linked data platform to represent the history of digital twins as a linked data platform container that holds representations of the snapshots of the state of the digital twin over time. And this would be how it looks like in RDF. And the interesting part about this is that it allows consumers that are compliant with the web standards directly interact with the history of digital twins. So no specific query language, I can just browse through time as well. And to sum up, so we propose a set of requirements for digital twin representation in ecosystems, and we analyze some of the state-of-the-art work in the area, and propose these two approaches, the ontology and the linked data representation. We would like to exploit refining this ontology and test it with actual use cases, and establish links with already other standards, and explore the use of the solid platform for access control, and experiment with hybrid data storage. And I will steal just 1 minute to advertise that with my team are organizing a workshop on digital twins, ecosystems, and applications at the International Conference of Pervasive Computing, and submissions are open. If you want, you can join us in Washington or help us as reviewers. Thank you.